Prakash. Today I'm gonna talk about the capstone project I've done for the GenAI Intensive Course, which I took a while ago. So let me actually introduce the course, talk about the course a bit, and then we can move on to the capstone project later. So it's a 5-day intensive course provided by the Google, and happened on March 31st through April 4th. And during this course, they taught us different things. For each day, there were like different things that, for example, day one has how to use foundational models, how to do prompt engineering, how to evaluate your prompts, structured outputs. On day two, we had RAG related stuff, embeddings, vector databases, and also in the following days, we had how to use AI tools. I mean, how to use function calling, tool calling to increase the capabilities of LLMs. So it was a great course. I did enjoy a lot during the course, and we were required to give a capstone project at the end of the course, and that's what it is right now. So that my project is Codee's form. So this is the notebook for the submission for the competition. Okay, so my project is Codee's form, and uh, it's a Kodee. The main part of it, it's Kodee, the farming assistant. So it helps the users with various things like managing the farmland, fields, controlling different things, applying tools, to solve certain issues. It has extensive tools to do a lot of things. Okay. Uh, so this is the UI of the application I built. Actually, this is not the first draft. So this was the first Figma design I made, like a basic ideation I had. So we had fields, and I also have temperature, humidity, and other parameters like mimicking the real world, and all, which have like sliders. So to like increase or decrease the temperature, we use the slider similar to and also other parameters as well. And there is a panel for chat, where a user can chat with the AI agent, which is Kodee, and get the results. And then we also have two more things, which are thoughts and tool usage. So in the thinking or thoughts, we have reasoning for every tool usage, or like every decision that agent makes. So it outputs what it thinks, and then what it's gonna do in the thinking panel. And then the tool usage, we can see what tools the agent is actually using to do what things. Okay. Let's actually, yeah, let's get back to the notebook, and I'll have a demo at the end of the video. So first, let's look into the Kaggle notebook. We have okay. So I have used same methodology and also same tools that were taught during the course. And so let's go through the notebook first. So initially we had I did setup of the environment and data exploration, just like how we were taught during the course. And there's an initial setup for the client, which is related to Gemini API. So yeah, and also of course I used Gemini models for all the parts of this project. So here I'm asking it to generate a small story with Kodee as main hero, and it did give us some good story, some good compelling story. And after that, I started with ChromaDB. So ChromaDB is for the vector database, and where you store all the data in like vector form embeddings for the better retrieval process. And for the ChromaDB, I made this like documents list where I have like data for each year, each field, quarter wise, like high resolution data for each field for past 2 years, like 2023 and 2024. So I did that, and after like using the Gemini embedding model, I inserted in the database, and this is what the like entry looks like. You have embeddings, you have data, and also you have metadata for a better retrieval. So this for querying part, it's really simple. You just use this query part and query function, and you get the information. And this function represents entire like retrieval and also generating based on the Retrieval-Augmented Generation. And the model uses this the retrieved documents to generate better answer instead of just saying I don't know or I can't access certain things, right? It's better for like when you don't want to give entire access to your database, but you just want to give it to relevant parts. This is the way to go, right? And yeah, it does get the details properly. So instead of like having this entire thing, I made it into a simple tool using which the agent can access the past memories. So I'm using the RAG part for retrieving the past memories instead of having the agent just telling the agent entire thing in one big query, system instruction. After that, uh, these are some basic tools I made to test out the capability of Gemini. Like for each tool, you have both positive and negative effect. Like for example, when you like do toggle shade, it's like having a shade on your field. So it decreases the temperature, but in the other side, you also get the effect of having more disease. Like your disease slider will get increased to 40. So it has both positive and negative effect. And yeah, that's how I designed the tool, so that the agent will understand the output, and based on that it will select the next tool, and it will do a planning and then execution. For and every execution step it will have updated list, and then based on the updated list it will take the next action. It's a step-by-step process. So that's how the entire flow works. So these are the optimal ranges I described. Like for example, 60 to 80 is the best temperature for field. It doesn't mean you don't have to be in 50 or 90. It just says that the 60 to 80 is the best range. That and using this optimal ranges, the agent will decide what tool to use, what exactly it needs to do. It makes better decisions when you have like a proper goal. So after that, I enhanced the tools and also increased the library. Instead of just having one or two tool, I made like 6 to 7 tool calls, and out of which I want to focus on two main tools, that are Google search tool and also image analysis tool. The Google search tool, it almost feels like an agent, separate different agent. It has a Google Gemini model that takes the image file and sorry, it's a Google search. So it takes the user query and does the Google search for the query and retrieves in relevant information, and then this information will be passed to the main agent that was using this tool, and the user you based on the information, the original agent will take the next best action. And similar to this tool, there is image analysis tool, where we are using a Gemini model to take the image file and do image analysis on that, and based on the description that this particular tool provides, the main agent will do the next best thing. So yeah, in the next cell, I'm mimicking the real world, like providing some values for the like temperature, humidity, and everything. And based on the values, and also I'm providing the system instruction, like these are the values current, these are the optimal values, and you have this image name, and also I'm mentioning whether you have memory access or not. And based on that, the agent will be planning its next steps, and then it will execute each step. So here I'm trying to ask, is everything okay with all the fields, and agent, the Kodee is looking into the fields and like seeing, okay, field 2 has some issue, field 3 has some other issues, so let me do this, that. And also I've provided some image which it was able to recognize some disease in it, and once it analyzed the disease and saw a tool that can help with the disease, it actually went ahead and applied the tool on the fields. So there are and also at the end, I'm like getting three things: thought list, tool list, and field snapshots. So thought list will have what the thinking process, the reasoning behind every decision, and the tool list will have the tools that the agent is using to achieve certain goal, and they do have timestamps. And instead of like, so I went the backend will do the heavy work and send this particular response to the front end, and the front end will take a response and do the simulation part. Okay, that's about the Kaggle notebook. Let me give you a small demo of Kodee. So this is the Kodee Codee's farm. Filters for real world simulation, I mean mimic, and we have fields, and also we have chat UI, thoughts, and tool usage. Okay, so these sliders will have an effect on the fields as well. So like when I move disease, it's really purple, right? But so the disease will have more effect on the field color, representing how bad the state of the field is right now. So green being good. Like, wait, let me, oh no, let me, what's that thing that's affecting the most? Oh yeah, humidity. Okay, so green being the most like really good field, and purple being the worst, and you have orange, like yellow, orange, red in between. So this way we can see the real like live transition of the fields, like for every tool usage. Okay. And also we have Kodee, the main hero over here. Right now it's humming to a song. Let's let's ask it a question and see if it's like working or not. So hi Kodee, how are you? Oh shit. Yeah, and also you can make mistakes. It doesn't matter because right now we're dealing with LLMs which are really good at understanding text. So it said, I'm doing well, thank you for asking. How can I help you with your farm today? So let me go ahead and increase the DCs. And also I feel like there is humidity, like a really low humidity. So let's see what Kodee does. So hey Kodee. Oh, sorry. Hey Kodee, something is wrong with field 1. Please help me with homies. Everybody's bad at this. With that. Okay. Oh shit, I made a typo. Okay. So right now Kodee is thinking and looking at the field, and like I'm planning its steps. So like we are getting analyzing field 1 condition. It says there is a fungi, there is a disease. Yeah, I did look into the disease, and also it felt humidity is really low, and it also needs to do some recovery treatment, and also it needs to do some pesticide spray. So you can see in live action how it's working. So after every tool you can see the toggle. Right now it's green, which means it did go ahead and solved the issues. So yeah, I hope you had you saw that, because it was really fast. I should have inserted some extra delay into it, but it's okay. Okay, that's that. So the agent just can directly interact with environment and take actions accordingly based on the like many things. So it also can like do like other things as well. Okay, let me demonstrate a simple like Google search. So is where in which state is Chicago in? Chicago is in. Okay. Let's see what tool it uses. So it used Google search twice for some reason, but it was able to pull proper answer. And you have 2 buttons over here. So one for the access to the memory. So I wanted to see whether like having access and also not having access have any difference, like answers. It will have a huge difference, but I wanna showcase it in the real time. So right now we don't have any access to the memory. We didn't provide any access to the memory for the agent. Let's see how it performs with RAG related questions. What Kodee, what crop did we harvest in 2023? So it says, I'm sorry, I cannot fulfill your request, and because since it doesn't have any access to the memory, it's not able to answer it. Let's actually turn the access on and see if it's able to answer it this time. Okay, so it used a tool called Query Kodee Memories, and in 2023 it says field 2 was planted with corn, field 3 is dedicated to potato farming, and also in field 1 I believe we didn't provide proper information about the crop in 2023 year. So yeah, that was good. Let me show you the image part. Okay, so these are some random images I found on Google. So I just did like most common plant diseases. So let me pick one random, like this one. Okay, so I can just copy and I can paste it over here, or you can even upload the image from your local desk. But yeah, you can do this one as well. Okay, once you paste this over here, let me ask, what is this in the image? Let's do. Okay, I'm also gonna add from this near in sorry this in field to take action. So let's confirm what that was. It was I actually don't know. Says something related to bacteria, fungus. Okay, let's see what Kodee did. Okay, image of black spot disease in field 2. I applied soil recovery treatment to reduce the disease level to a healthy range. So yeah, if you had looked into it, so it was near 70, right, when we increased before shooting this message. So now it decreased to that, and it also triggered other things as well. So initially it used image analysis tool for analyzing the image. So like you can see in the thoughts what's exactly happening in the brain of the agent, and then it used other tools to do some other things as well. Okay, let's so that's we have this. Okay, let's do one more. So there's temperature, humidity. Okay, let me increase temperature, soil fertility, disease. Field 2 looks off. Can you help me with that? Let's see what the agent does. And also, every time issue comes, the agent will take a different path. It's not like there is a certain path of doing like the work. So right now, okay, there is an issue with the output. So sometimes there will be like issue with this output. So but it did apply some like tools, and you can see what's happening. Using high disease low field in field 2, and it used soil recovery treatment, and then it used emergency cooling to reduce the temperature in the field 2. Right now it's 75. It was around like 90, right? Yeah, it used some other tools to solve certain issues. Okay, so that was Kodee, the agent, the farming agent, and that's the thought and tools, and yeah, that was about it. And no, let me actually give you a glimpse into the code of backend actually. Wait, I think I made a slide for that. Okay, so this is the backend, full stack aspect of it. So I used a React for the front end and Flask for the backend. So and also it's enabled by Gemini. Let me. Okay, so in the when user sends any request over here, it shoots a API call HTTP request to the Flask server, and it sends user message, field state, and also these toggles for like several things like document access, agent mode, and also option file, which is uploaded image. So if user adds an image, it does get added to the request as well. And then once Flask receives that image or all this request, it starts processing it, and then it let me why don't we just go through this app. Yeah, so let me show you the server logs we had. So this is what we did last few requests. So these are the snapshots that are sent to the client. Okay, let me start with something simple. This is the front end, sort of backend part of it. So you can see there is an app.py where I have listed, where I have written the code for the main function. So that's a lot of code, I know, but most of it doesn't actually, it doesn't require it to be there because it's mostly demo part. So I just want to have a backup to show the app, but since it's working, I actually don't need this demo part. So yeah, so we have ChromaDB where so this is how I set up the ChromaDB. I have a JSON file where I had the information set up, and I used the same functions that were taught during the courses to populate the databases with embeddings, metadata, and everything. And I used this is the tool that's being called by the agent. Okay, yeah, maybe I forgot to include the query. Okay, so agent uses docstrings for better tool usage. So right now this one doesn't have docstring, but still it's able to use it, because I feel like since there were like a lot of conversation happening before it figured out this is the tool for the memories maybe, and also the name of this function tool has memory in it, so probably that's one thing that's helping the agent to use this tool for memory related stuff. But if you look into other tools um, like solid recovery treatment, we have arguments like field ID. It needs field ID for taking any effect, and we are recording the tool usage, and we are updating with certain parameters, and then we are returning the fields. And let's look at the other tools. So this is the image analysis tool. So here we are like passing a prompt and also the image that's being sent by the client. So in the my file we are sending this file, and also in the prompt we are sending this prompt. And using this prompt and image, there will be a different agent that will be created, and this agent will do the Google image analysis part, and once it's done with analyzing the image, it will respond to the main agent like hitting back with description and the analysis part. And the main agent uses this analysis to do the further thing, which is like, let's say the image has some fungi disease that needs to be handled. It uses some tool to handle that particular condition. And then we have Google search, and it needs a query like string for like doing the query part, and also we have response, like what it returns. So this is the example usage of how this tool is being should be used. So we are like recording every call. So initially I actually tried recording with the Gemini itself using prompt, but it's not working well. But I went ahead and used like one more tool which records every tool that's being used, so that we can show it in the front end. And also the front end, the React and the backend, the Flask have their own simulation. Like one will have its own simulation part, and the backend will have its own simulation part. And so for example, the backend will be started with different field values, probably like 0, so everything will be 0. But when the front end sends a request to the backend will or the Flask server will just update the field values to the current field values sent by the client. And once updated, it starts doing the agent like query handling part based on the front end. So if the React query was something like handle field 2, then the agent will start looking into the values that's sent by the client, and also it will look into the tools it has, and then does the planning and then execution accordingly. And once the backend is done with its simulation, the execution part, handling part, it will do the simulation within its like space. So once the simulation is done, it will send the snapshot of what tools, like we are recording the tool calls, right? And also we are recording thoughts, and also we are recording fields snapshots. So for every action, we are taking a screenshot of what fields look like. So using these timestamps for every item like thought, tool, and also fields, we can simulate that like live feed going on in the front end. The actual like real way of doing it is to have a streamlined application. Like every single thing, like backend will just take one action. Let's say the agent takes an action, it should be implemented in the front end, and once the front end is done with implementation, it will send a request or a streamed, like there should be streamlined like communication, but it's a little more complex for this. So I went ahead with like separate, like just HTTP based distributed system kind of way. So the Flask will have its own space where it emulates the entire thing, and then it sends the like whatever it has done from start to finish to the front end. The front end will just take the input from the server and just shows it in our face in the screen. That's it. So yeah, I like kept it very simple so that everyone can understand that, right? So that's about it. That's about the tools. So there will be a folder for this specific reason where the user sends the request with the image, and we are handling it in a way that we are storing it in somewhere like upload space from where agent can access the file and shoot a Gemini model to do image analysis part. So that's front end, lot of code. with components, chat, metrics, processing, and everything, and also there is backend. So that's about the full stack aspect of it. Yeah, that's about the Kodee form. It was really good working on this project. I really liked like how AI we can use AI to do a lot of things. It almost feels like like it almost feels like cheating, because since AI can do anything, you just have to shoot a API call, right? You don't even have to do the pre-processing, post-processing. A lot of work can be handled by the AI agent itself. So yeah, so thank you for watching, and um, that was about the Kodee form capstone project. Thank you.